Hey guys and gals, it's Mr. Good, and I was just going to make a video on notes for 1.3 and 1.4, so you actually need to get a piece of paper and write down some. They're not very long, but they will help you out on your worksheet on our review concepts. So, first thing, you can find the video on our well, you're already in the video, so who knows how you found it. But you can always find the videos in here. On our lesson plans, you should be able to get to everything you need. This right here is part of your notes. I want you to review parent functions. So if you click on there, it'll open up this slide show of just a review of parent functions you're supposed to already know. So they shouldn't be like magical. You should have seen them like in Algebra 2. You should have seen them in pre-calc. So like you have constant, linear, quadratic, cubic, and look at all what they look like, all real numbers, the range and domain, and zeros and stuff. So basically, go through here, take a good look at them, get re-familiarized with all the different types of parent graphs because we're going to work with them all year. And then you can see what our homework is. So let's hop in there. You can also check out the stuff on our classroom page. So if you would get a piece of paper out, and we're going to do some notes. You want to have these in your notebook, so when it's time to go study for our quiz that comes up, you will be prepared. All right. So let me make that as big as possible. Okay. All right. So the things in 1.3 and 1.4 are how to find x and y intercepts, equations of lines, and parent functions. This right here is going to be just in the slides that you can find on Classroom or that link. Okay, so really we're going to do just how to find x and y intercepts and equations of lines. Both these things you've done before, but that's why we're reviewing it. So x and y intercepts, if you've forgotten, to find x-intercepts, all you have to do is set y equal to 0 and solve. Okay, to find y-intercepts, you just set x equal to 0 and solve. Okay, pretty darn easy, right? So let's try a couple out. First, we'll start off ridiculously easy and say, okay, if I want you to find the x and y intercepts, which is a pretty important thing. We'll do a whole thing on curve sketching with calculus later. That's why I'm asking you to refresh your mind on this. Okay, so if this is my equation, I want you to find the x and y intercepts. I like to keep my work organized, and if I'm finding x-intercepts, I write x-ints, and to find an x-intercept, you simply set y equal to 0 and solve it. And some problems were really easy. I started off with an easy one, you know, because why not? It's the beginning of the year. So divide both sides by 2. We have one x-intercept at -2. That makes sense because the most amount of x-intercepts you can have is the degree on your equation. And since this is linear, that's a degree 1, and there's one answer for an x-intercept. Okay, now keep in mind, what does this mean? This means my graph hits the x-axis at -2. Or if I were to write it as a point, it would be the point -2, 0. Right? That's really what that means. It's an x-intercept. Now when I go for a y-intercept, I write it here. You know, I'm kind of keeping my work separate. I set x equal to 0. I usually don't even bother writing 2 times 0 because, well, I know what 2 times 0 is. But, you know, for the sake of notes, let's do that. So y equals 4 is your answer, but what it really means is your graph hits the y-axis at 4. So I'm going to go ahead and say that's actually the point 0, 4. So I would know without even needing, my graphing calculator, even though they're cool. I already know my graph hits there at -2. It hits up here at 4. I already know that's what my line looks like. Okay, we're going to be using that later with calculus, but this is a skill you have to remember. Now, one thing I do want to warn you about is not every problem has just one x-intercept. They sometimes get a little weird and they're harder to figure out. Like you have to remember how to factor and stuff. All right, so we can do one that's like y equals x squared minus 9. It seems harmless at first because you're like, okay, x-intercepts. I'm going to set y equal to 0. Now, if you think about what this equation looks like and you know your parent graphs, you should already kind of know that this is a quadratic, so it's going to be U-shaped. It's going to be going upward, opening up like a U, and the whole graph is shifted down 9. So if I were a betting man, I would guess it looks something like this, right? So x-intercepts is asking where it hits the x-axis. This is where knowing parent functions really helps you, because a lot of you, if you weren't paying attention and you were just like in math mode, you would be like, okay, x-intercepts. I simply set y equal to 0, and I solve this equation, right? And here you're like, oh, square root both sides, right? And you're not wrong, but most people make a rookie mistake here and they say, what's the square root of 9? It's 3. I'm done. My x-intercept's 3. Well, guess what? You missed one of them. If you just found out that one is 3, you missed this guy here. And that's because whenever you take the square root of a variable that's squared, you have to remember it's plus or minus the other side. If you make a mistake like that, it's a rookie mistake, and I have a special stamp for that, because if you forgot the plus or minus, I would do that to your page and say, rookie mistake, plus or minus. Okay, anyway, so don't miss one of those. Don't forget that there's two answers with the squared root. Anyway, I could give you a different problem. Oh wait, that was x-intercepts. So that's actually the points 3, 0, and -3, 0. Okay, and then the y-intercept is actually a little easier. Y-intercept is always easy. You put in 0 for x. I guess I could write 0 squared, but it's still 0. So y-intercept is -9, which means it's the point 0, -9, which means this guy down here hits at -9. So I could make a pretty accurate graph if I just knew the shape of my parent graph and I found the x and y intercepts. It's actually a decent looking graph. All right, so that was a review of those. The next thing we're going to review real quick is how to write the equation of a line, because we're going to be talking about something called tangent lines a lot in calculus. So let's review how to write the equation of just a normal line. Okay, so the second thing we're going to do here is find the equation of a line, and there's basically two different rival gangs in the equation of a line world. There's a slope-intercept gang and the point-slope gang. They always think theirs is better. So not everyone. Most people prefer slope-intercept because it's fun to say y equals mx plus b, where m is your slope and b is your, don't just say intercept, but say y-intercept. Remember how we just found y-intercepts? Well, there it is. Okay, super easy, right? Most people remember that. The other way is this, and most people don't give this one enough credit. I actually like point-slope form of a line because you still have slope, right? That's still slope. But if you just have a point, x1 comma y1, then the x part goes right there and the y part goes right there. It's pretty handy. Okay, so it depends on the problem, like you'll see in your homework. Maybe I should make that a 4. All right, so basically there's three different situations you could be in to write the equation of a line. The easiest thing possible is if they give you a slope. So if I tell you your slope is -1/4, and I say, and your y-intercept is the point 0, 5, can you write the equation of a line? Well, as long as you are familiar with this, which, holy cow, if you're not, yeah, oh man, so this is almost insulting. I don't mean to insult you by this. So if you give a slope and an intercept, can you write the equation of a line? Yay, huzzah. Okay. The next step up in difficulty is if they give you, if they say the slope is, let's say, 2/3, and it goes through the point, let's say 6, 1. Can you write the equation of a line? Now, there's two different ways to do it. You could do slope-intercept and plug in your m for slope, obviously, the x part of the point for x, and the y part of the point for y, and solve for b. But I think that's wasteful because guess what? If you have a point and a slope, you know what you should use? Point-slope form. So I'm going to write, just remember, this is x1 and this is y1. So I'm going to follow this formula. Y minus y1 equals m, actually I'm going to make this a -6 just to show you, equals m, which is 2/3, times x minus x1. Now this is why I made it negative, just to show you in notes. If I'm subtracting the value of an x1 and it's already negative, I want to make that a +6. So just to show you, you change the sign. If this is a 1, you make it a -1. If this is a -6, you make it a +6. And then technically that is the equation of a line. Now if you want to get really crazy, you know, which who doesn't, you can distribute this, and 2/3 times 6 is 4, right? If you need a calculator for that, shame on you. And then add 1 to both sides, and there's the equation of a line. Technically, I could have stopped here because is that an equation of a line? Yeah, I guess so. And then worst case scenario is if you have just 2 points. So if I gave you the point 1, 4 and -5, 2, right? Well, the problem with this is you don't know slope or intercept, so you have to find slope. And remember, slope is your rise over your run. So the difference in the y's over the difference in the x's. And I know a lot of people put 1 in, you know, y1, y2, y. It doesn't matter. What does matter is you follow the leader. So if I go 2 minus 1, or minus 4, right? Here's your y value, here's your y value. If I go 2 minus 4, I have to go -5 minus 1. If I started with this point on the y's, I have to start with this point on the x's too. So I go 2 minus 4 over -5 minus 1. It's rise over run. And that is -2 over -6, also known as +1/3, because a negative over negative is a positive. So I found my slope, and I have a point, so I can use point slope again. Now, does it matter which point you pick? Good question, self. The answer is no. So which one do I pick? The one without negatives. I mean, why live life negatively? So you're going to do y minus 4 equals m times x minus 1. You could also do it with a 2 and a -5. It comes out to be the same. You can FOIL that and get to the answer if you want, or you could leave it like that. All right, that's your notes. Hope you enjoyed. And now you should be able to do your homework worksheet and celebrate. All right, talk to you later. Why am I wearing a mask? Oh. People came in the room and I talked to them for a while. So anyway, there you go. Talk to you later.